Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Markovnikov's rule states that in the addition of HX to an alkene, the hydrogen adds to the carbon bearing more hydrogens, or the more electron-rich carbon, and X adds to the carbon bearing fewer hydrogens, more substituted or more stable carbocation. Anti-Markovnikov violation occurs when the addition goes opposite to this rule, typically when the double bond carbon is attached to a strongly electron-withdrawing group. Moving on to the next step. Analyze each substituent attached to the vinyl group, CH is equal to CH2. Option A. CH3O is an electron-donating group, EDG, via lone pair donation plus M effect. The oxygen donates electrons into the double bond, making the alpha carbon, CH is equal to more electron-rich. HBr adds in Markovnikov fashion, H goes to CH2, Br goes to CH bearing O. This follows Markovnikov's rule. Option B. CH3NH is also an electron-donating group, EDG, via lone pair donation plus M effect. Similar reasoning as A. The nitrogen donates electrons, making the alpha carbon more electron-rich. Markovnikov addition occurs. This follows Markovnikov's rule. Option C. CH3S is an electron-donating group, EDG, via lone pair donation plus M effect, though weaker than O or N. The sulfur still donates electrons into the double bond. Markovnikov addition occurs. This follows Markovnikov's rule. Option D. O2N nitro group is a strongly electron-withdrawing group, EWG, by both inductive I and resonance M effects. The nitro group withdraws electron density from the double bond, particularly from the alpha carbon, CH is equal to. This makes the beta carbon is equal to CH2, relatively more electron-rich. When HBr adds, H goes to the carbon bearing the nitro group, alpha carbon, and Br goes to the terminal CH2, beta carbon. This is opposite to normal Markovnikov addition, hence Markovnikov's rule is violated. Moving on to the next step. EDG groups O, N, as attached directly, activate the alpha carbon, leading to Markovnikov addition. EWG groups, like number 2, deactivate the alpha carbon and reverse regioselectivity, leading to anti-Markovnikov addition. And for the final step, options A, B, and C all have electron-donating heteroatoms that direct addition in a Markovnikov sense. Only option D has a strongly electron-withdrawing nitro group that causes anti-Markovnikov violation addition. Therefore, the correct answer is D. Therefore, the correct answer is option D.